let's classify some polynomial functions. But first, we should know exactly what a polynomial function is. A function is considered a polynomial if its powers on x, the power on x has to be a non-negative integer. So 0, 1, 2, 3, 4, no decimals, no fractions. So that right there, those powers are all positive numbers. It's okay if you've got a coefficient in front, like that. It's okay if that's a fraction. But the power on the x can't be. So let's look at some different types. The ones we're going to concern ourselves with are constant functions, linear functions, quadratic, and cubic. They keep going up higher to a higher degree, but this is what we're going to worry about. A constant function has a degree of 0 because the x has a power of 0. It's not there. A linear function has a degree of 1 because the power on the x is a 1, the highest power on x. A quadratic function has a degree of 2 because the highest power on x is a 2. And a cubic function has a degree of 3 because the highest power on an x in these functions is a 3. If I look at a constant function, f of x equals 2, something like this, what it ends up looking like is a straight line. So a straight horizontal line that crosses the y at 2, which means it doesn't matter what the value of x is, that y value is going to be 2 everywhere. That's what a constant function is. Now remember, this one has a degree of 0. A linear function is going to be a straight line on the graph when we draw it. As you can see, this follows the form y equals mx plus b. This one has a degree of 1, because that's the highest power of x. And that will always be a straight line of some sort. As we get further into the polynomial functions, get into a higher degree, we start getting a little more complicated graphs. This one is a quadratic function, and it has a degree of 2, because the highest power on the x is a square, is a power 2. This one has a degree of 2, has one turning point. It was going up, now it's going down. Or, if it's drawn the other way, it may be going down, then has a turning point at the bottom. It could look like this, all depending on what the function is. As we keep moving up into the different types of functions, we now have a cubic function. Now, if you remember, a cubic function has a degree of 3, because 3 is the highest power on that function. Now, this one looks a little more complicated. Degree of 3, it's going to have 2 points where things change. This is what a cubic function looks like. The next thing we need to look at with functions is the leading coefficient. Now remember, coefficients are these numbers that are in front of the x. So in this case, this is one of the coefficients. This 5 in front of the x is one of the coefficients, is the leading coefficient. This minus 4 in front of the x is the leading coefficient. Same thing with this 2/3 and this minus 3. Now these numbers back here are also coefficients, but right now we're going to worry about the leading coefficient because it will tell us something. So in this case, my leading coefficient, also referred to as a, is minus 3. In the linear function, my leading coefficient is 2/3. On my quadratic function, my leading coefficient equals 5. And on the cubic function, my leading coefficient equals minus 4. Let's talk about what we can figure out using the leading coefficient. When we're looking at the leading coefficient, you have to remember your quadrants. When we have our xy coordinates, this right here is quadrant 1, that's quadrant 2, that's quadrant 3, and that's quadrant 4. 1, 2, 3, 4. Now your leading coefficient is going to tell you where the endpoints of the graph are going to be. Where does it start? Where does it end? Let's start by looking at polynomials that have an odd degree. If your leading coefficient is positive, if a is greater than 0, the graph is going to start someplace down in quadrant 3. And it's going to end, or it's going to continue on and end someplace up high in quadrant 1. If your leading coefficient is negative, if it's less than 0, then your graph is going to start in quadrant 2, so your top left-hand corner, and it's going to end up down in the bottom right in quadrant 4. Now it's not saying what it's going to do in the middle, but that's what the end behavior is going to be. If we look at even degree functions, so functions with an even degree, if my leading coefficient is positive, it's going to start in quadrant 2, and it's going to end in quadrant 1. Just like a parabola that opens upwards. If my leading coefficient is negative, it's going to start in quadrant 3, and it's going to end in quadrant 4. Just like a parabola that opens downwards. Once again, this doesn't say anything about what happens in the middle. These are just the endpoints. So this is something you need to remember when you're looking at polynomials. You have to remember what the degree is. You need to be able to roughly identify it from a graph. And you need your degree and your leading coefficient should be able to tell you what the end behavior of the graph will look like.
Thank you.